Let's look at the history of the cloud because many people think that it's very modern, that it really only has come up in the 21st century, but actually the origins of the cloud go back a long way. In fact, they go back to the 1960s. By the end of the 1960s, all the necessary elements of cloud had been developed in some form. So they may not have been put together as cloud computing, but everything that cloud computing needs and stands for was actually developed by before 1970. So the concept of computing as a service was first put forward in 1961 by an early AI researcher, John McCarthy. Virtualization is the backbone of how computing services are delivered on the cloud, and that was pioneered in 1967 by IBM. They were the pioneers for various operating systems, and they produced the first virtualized operating systems and time-sharing operating systems where you had multiple users on the same computer. And in essence, that's what you're getting with cloud computer. It's back to the future. We are looking at putting a lot of different virtualized systems onto a single or a single set of computers, and that's what was actually pioneered in 1967. And obviously we need networking. So networking got its start with ARPANET in 1969, and that's also where when TCP/IP first appeared. So it's quite amazing that the protocol that we still use as the backbone of the internet, TCP/IP, was actually developed in 1969. So if we look back to the very beginning, 1961, we have this quote from McCarthy where he said, "Computing may someday be organized as a public utility, just as the telephone system is a public utility. Each subscriber needs to pay only for the capacity he actually uses, but he has access to all programming languages, characteristic of a very large system. Certain subscribers might offer service to other subscribers. The computer utility could become the basis of a new and important industry." And while obviously this is couched in terms of the 1960s, where computers were what you see him in front of, where they were very large, they had tape to store various things on, they didn't have graphical interfaces, they didn't really have networking, but this whole idea of sharing as having utility, having something that people can go in and pay for and only pay for what they need, is something that was actually there from the beginning. So if we look before the 21st century, we see that all the foundational technologies were already being defined in the 70s and 80s. All the networking, all the different operating systems were already being developed and perfected during those years. We also have the emergence of distributed computing, or the client-server model. And this became very popular in the 1990s, and we did have grid computing emerge at that time, and these are really the predecessors for cloud computing. And by 1991, the World Wide Web was launched, and we then had the internet, where everything is considered to be connected. And if you're not connected, there's definitely something wrong. Now, the grid actually is a very early version of a part of the cloud. So grid was defined and utilized mainly for scientific and engineering computing, and it was actually a response to the fact that a lot of scientific computing had been done on large supercomputers. But the fact is there were very few of them, they were very expensive, and very few people had access to them. But what they did have access to were lots of simple, small computers that could be networked, and then grid computing was how do you connect them together and allow people to have access to them. So a lot of that middleware to organize that actually, in essence and in concept, looks very much like what we have now with cloud computing. So the cloud emerges in 2002. This started with Amazon Web Services. They were the first public cloud Their first generation was really a centralized infrastructure for data storage. Their first business was storing data, and it's still a huge part of their business to this day. They really wanted to be the back end to other web supplied front ends. So once again, the client server model was being used. And their Elastic Cloud, Compute Cloud, EC2, appeared in 2006. And so what we have is we have various things like cloud storage as a service coming up. So things like Dropbox. We have EC2 forming the basis for people getting virtual machines that they could do their compute on. And all of that was in the early 2000s. With this, we started getting a proliferation of data centers in multiple regions. So now we have something that actually is starting to be different from what we saw in the 20th century, which is now we're looking at infrastructure being replicated, being hardened, having more quality of service considerations. So what we see here is that we have the idea of the cloud giving you much more than just storage and computation. It's also giving you security, replication, fault tolerance, and they're looking more to what kind of services can be provided and looking at it not just as infrastructure, but as service. Now, we also have by 2009, there was a standard definition for private cloud architectures and stacks, and we have OpenStack appearing in 2010. So now, instead of just being the domain of Amazon with AWS, we also have the ability for organizations or indeed individuals to set up a private cloud architecture. And then we had the next big player that comes into the public cloud domain, Microsoft's Azure was launched in 2010. So you can see there's a fair length of time between AWS appearing in 2002 and Microsoft launching Azure in 2010. So we have those are the two largest right now, but there is still almost a 10-year difference in how long they've been around. So if we look at the second generation, this is really from 2012 really up to now, and now we're starting to get into the next another generation, but we're still really in the second generation. We see a proliferation of services, and we see more providers coming in. A lot of the services that are there are also services that are there for monitoring the infrastructure, monitoring the services, and so there's increased trust in what's being provided by the cloud. And so now we have many sectors in society, business, institutions, organizations that are starting to adopt cloud. And in fact, sometimes they're adopting cloud in a way where you don't even know. So the streaming services, people don't really think of that as cloud, but definitely it is there because of cloud. So now we get in generation 2 all of the different concepts that we're used to now with cloud. So pay-as-you-go pricing, so the notion of you pay for what you need, you can increase what you need based on monitoring and pay for that, and then shrink down when you don't need it and then pay less. We have, as I said, the real-time streaming services, and we're now more and more hooked on having real-time streaming services, and what we're seeing is a proliferation of them and more need for better performance. And we also are seeing now database services going into the cloud and having everything from very light SQL databases up to non-SQL up to high performance databases. Obviously cost a lot to use, but you have a whole range so that you can provide almost anything a modern corporation or organization or research institute would need, and you can do it in the cloud. In 2014, there was a major addition to the cloud, and this was container services. And once again, this goes back to this notion of virtualization. So the cloud is really made possible because of, or at least easier because of virtualization. And one thing that has made virtualization easier right down to the sort of the service level is the notion of containers. And we're going to look at containers and their services later in the course. We also have the emergence of heterogeneous clouds where we have all sorts of different types of infrastructure going into the cloud. So we have everything from GPUs, tensor CPUs, and now we're starting to get into even some quantum hardware being provided. And we also have particularly industry moving into the notion of the hybrid cloud, where you can combine public and private clouds so that you can place the different services or parts of the service into the cloud based on your comfort, usually with security and privacy for that portion of your service. So whatever you're doing, you want to say part of it might be public, part of it might be on a private cloud. Now, one thing I want to draw your attention to is that as soon as you start getting a technology that becomes is becoming very ubiquitous in the world, where everybody's using it, where there's a lot of availability, you also see the needs for standards and documentation about what's out there. So one of the things that I've provided as reference material is this reference architecture and taxonomy document that was produced by the National Institute for Standards and Technology in the United States. They did this in 2011. And what's very interesting is that most of what you see in this document, even though it was produced in 2011, is what the architecture is nowadays for the cloud. So we're moving into a next generation, but this document is very good at capturing the current generation. So if we look at the conceptual reference model that's there, we can see a lot of the things that we're going to look at in the system. We can see the service layer, the systems as a service, the infrastructure as a service, the platform as a service. We're getting more added onto this now, but these are the major ones that everybody is providing now. And we can see the different emphasis on auditing, having security, privacy, looking at portability, worried about what the hardware software mix is. And all of this is actually very much still the model for cloud systems. We also see in this diagram the notion of what people would actually be doing, particularly with these various notions of services, whether it's infrastructure, platform, or software systems. So we have some examples here, and they're still fairly relevant now. Not much has changed with regards to these different services. And if we look at a cloud provider, we can see that they orchestrate a whole bunch of different services that they're providing outside of what you're providing as a user of this as a service to your customers or to yourself. And they are concentrating a lot on the notion of they control things that are actually the very difficult parts to provide in your own compute center or data center, involving the infrastructure, particularly for security. And we're going to look at security in this course because this is obviously a huge problem for all systems now, and it's getting worse, not better, about the attacks that are going on. And we're going to look specifically at the difference between you providing your own premise infrastructure, on-premise infrastructure, and choosing to go into the cloud, because there's still debate about this. There's still misconceptions about the difference in security between these systems. And with this, we can see this idea about the different control layers. And this actually, we'll see when we look at security, is very important, because who's controlling these various things? So if you're doing your own system, you have to look at all of this. You have to be aware of updating your operating system, making all the patches. You have to look at the networking. You have to monitor for attacks or monitor who's logging in. A lot of this, depending on how you use the cloud, is done by the cloud provider. And depending on how you decide to take the services from them, it decides what you have to do and what you let the cloud provider do. And just to complete this, if you look at the taxonomy, so in other words, how we could break up thinking about this and how we could look at the various organizational layers for the cloud, a lot of this is still something that you can learn from, because it's telling you what are all the different things that have to go on in a cloud. And it also informs you of how the cloud providers talk about their services. So in all of this, it's very good to be able to understand the vocabulary that's being used and how it's being used. So I mentioned that there is coming a next generation of cloud. And what does this involve? Well, a lot of it involves things that are becoming increasingly interesting to software developers. So things like microservices or serverless functions, breaking things down to very small parts, not monolithic systems, but very small microservices is one way of looking at architectures. And that's being more and more facilitated by cloud services. And this also gets into the whole idea of DevOps. So the cloud is providing you now with everything you need to do to actually provision your development cycle and move through it. And so you can take advantage of all of the different development software and systems that are out there, because they're being provided in a very curated, managed way by cloud providers. We're also looking at how the cloud infrastructure itself is changing, and that's to getting outside of the major cloud centers and things like edge or fog computing, where you have smaller, closer nodes that may not be as high powered, may not have as many things as the main cloud center, but it resolves some of the issues involving traffic and latency. Now, this was first suggested in 2009, but now it's becoming realized by some of the cloud providers, where you can actually choose to move some of your processing and data closer to the users of those things that you're providing. Another thing that's driving some of the innovation, obviously, in the cloud and some of the services that have to be provided is the Internet of Things. So with this, you're going to have billions, not hundreds of thousands, not millions, but billions of small connected devices that have to send and receive data from some other center. And that right now, increasingly, that's the cloud. And so as more and more things become sensorized, if that's a word, but where you have all these sensors in smart cities, smart farms, smart hospitals, anything, all of the different smart homes, all of these different devices we have to get the data from them, and then we have to do things to it. So that may be data mining it might be control, it could be all sorts of different things. And so we have this issue about how do we handle this, and how do we handle it when a lot of that processing has to be near real time. And this will come up when people get into actually controlling cars or transportation units by networking and by the cloud. And with that, there's going to be huge need for performance and low latency. With all of these things, and particularly as we get into the Internet of Things, security becomes a huge concern. And so there's more and more work being done to see where the security provisions are put into the scheme of things. So what lies with the cloud platform and providers themselves, and what has to be done by the user of those services. So this is a very exciting area, and it's very new, where people are actually trying to understand the difference between the security concerns in the cloud and the security concerns in traditional on-premise systems. And as these services become more and more ubiquitous, then we have to worry about the costing model for this, because if everything is being pushed that way, how is this going to be costed out? Is it going to be affordable when you have billions of devices connected to the system? How are we going to actually be able to afford all of this? And this is becoming more and more critical when we look at the situation we have now, where we're in a pandemic and with people in lockdown doing education online, doing business online. More and more things are being pushed into these cloud systems. Are we actually going to be able, how are we going to be able to afford this, and who's going to be able to afford it? So I'd like to leave you there's in one of the readings that I've posted, there's a timeline where it gives you a more in-depth view of all of the different things that I've been talking about in this module. So, have a read with those. I think I've put 3 documents in there. They're not all, well, 2 of them aren't very long. Have a look at that, particularly on the history of the cloud, because it's very interesting about where it's been and where it's going, and what are the major conceptual premises for cloud, because understanding them makes it much easier to understand cloud and where it's going and how you might want to get involved with developing the cloud. So I've got these readings up there: History of the Cloud, Cloud Futurology, and then I've also put the NIST Cloud Computing Reference Architecture. Obviously, you don't have to read through all of that, but it makes a nice document to browse through to see if you understand what the terminology means and what are the standards for cloud.